will talk about the security design of security barriers. If we have successful break-ins, and we have to always think about that we somewhere have a successful break-in, that we somehow make it harder or maybe impossible to go at least to the backend services as an attacker, and also how we could make it easier for the forensics later after a successful break-in, what we could do to do in the beginning to log everything. Yeah, and this is the agenda for today, and we want to do a short introductory round until 1:30, and then we will talk about, as I said, concepts and experiences with security in HLRN. We will then have Pascal Brückner from TU Dresden, who will report about the actual break-in. We have a short coffee break. Then we talk about two-factor authentication, what we have in, not related to HPC in general, but for admins or also for users, this could be also useful in HPC area. So Ralf Krimmel will talk about the software privacy idea and what we do there in GWDG. And yeah, and then we have a short talk from Holger Granikov from Athos, who will talk about security in HPC with containers. And then we have conclusion and discussion. I made a presentation. I think it will last for 1 hour. If not, then we can maybe discuss a bit later after the presentation about all the security related thoughts we made when we started with HLN, what Christian Köhler just said at the beginning with the security concept, and also experiences we had. Yeah. So, we have, or I have made 3 topics out of that. The first topic is the problems you might not think of when you set up an HPC environment. I mean, you usually start with some kind of cluster management system, probably, and you will have a default installation of a, for example, CentOS OS or some kind of Linux distribution, usually a clone of a Red Hat Enterprise Linux when you drive an HPC environment. And the differences we will talk here about in this topic to your local computer, what you should not do in the HPC environment. Then the next topic is especially what we requested from the winning vendor of the HLN4 procurement. And this security concept was at first developed by Hinak Stüben from Uni Hamburg. He was not able to join today because he had a different appointment. But yeah, we will see what special things. I mean, this already includes, of course, the topics from the first point. And then we had a certification of our system from the DFN CERT. And there were also some kind of recommendations what we should change to make it easier, as I said in the beginning, to the auditors or to the forensics people when we have a break-in afterwards, and that we have locked the relevant stuff, and also, of course, to make it more difficult to break in deeper into the HPC system when we have a break-in attempt. So, problems you might not think of. I mean, if you have a Linux system and you mount an NFS share, for example, you probably rely on the defaults of the OS. That means you put in the in the FS tab, probably as for the options defaults, and then this populates to RW, LR time versus 3, a certain R size and a W size, and so on. I didn't want to show all the options here from the default of the CentOS installation. That's why I did not. That's why it's running out of the slide. But you see the idea. You just put in defaults and then it mounts with default options. This is also true for other file systems, of course, which are globally, like Lustre. Then I just checked on our system. We have RW, FLOC, and lazy StatFS. That was our options. But if you are a bit in security with clusters, you might already see that we do not have set no SOID and no def. And that means if you have a cluster and have a machine which is not on the current patch level and have security issues, for example, because certain software is not able to be run on a current system, so you have one machine where the people can log in on an older OS version to be able to run that software. But this machine has the same global file systems mounted like all the other machines. Then you might have a problem when you don't mount with no SOID and no def, because the hacker could then also log in, of course, when he got a legal user ID, which he might have hacked somewhere or found or whatever. He can log in as a user, and then he finds this machine which is vulnerable. So then he gains root there because of an old security flaw, and then you have these global file systems. He can put a S-bit binary on that file system, and then logs into one machine which is usually not vulnerable, and starts that binary there and gains root there, even if there's no real security issue on that system. So if you mount, if you have a homogeneous HPC system where every node has always the same patch level, then you can mount without these things. But if you have one machine or a few machines which are not on the same patch level, and this is very likely the case if you have lock-in machines, for example. The lock-in machines, the people start programs there, redirect ports or whatever, and you don't want to boot them all the time. So they are probably maybe a bit older kernel, whatever. So you have to trust all machines which can mount this file system if you don't set no SOID, no def. So, and we now have a look at such thing. So let's say this is a a patched system where we have and I'm the hacker and I didn't get root there. So I found another system where I got root because this was not patched. And we say, okay, this home directory is a global file system, and on this machine it is mounted without no SOID and without no def, so with default options. So what I can do now, so this is an empty directory, I can now just take the bash, say change mod change mod A plus S, so set an S-bit for root and group root for that shell. And now I'm on the system which I could not, where I could not gain root as an attacker, but I have this globally mounted files, or this global file system which is mounted there, and I now find the same file there. Now I just call it and I'm root. I'm really root. Yeah. So that's the first thing which you should not, why you should always set no SOID. So that means the hacker cannot do that because the S bits will be ignored on the other system. So what the other options, or what about the other option, no def? First, you would not think maybe that this is security related, and you maybe leave that out and just set no SOID or no SBIT. But what you can do as a hacker, I'm again on this vulnerable system where I got root. And let's say this system has the root file system SDA1. Yeah? I mean, it does not have. I can show you. It's just a USB stick, which I put into the system here. So my root file systems are on the NVMe, on the NVMe SSD. But let's say SDA1 would be the root file system. So what I can do now is I look for the major and minor number and do the same here, block device 81. And now I created a block device with the same major and minor number like SDA1. Now I say change mod 777. Right? And now everybody can read and write to that device. Now I'll go back to this system where I could not gain root. And I have now this device file. And really, I can read SDA1 on that system as a user. And I'm not part of this group disk, which can do the same. Yeah. So this has nothing to do with the real /dev SDA1 device. Just created the same major with the same major minor, so it will go to SDA1. And if I allow everybody to read and write to that device, I can read it. So what can I now do as a hacker? I will get the whole device. This is very small here for demonstration. I would now have the full image of that partition. I could copy that to my local notebook, mount it loopback, and put an SBIT binary with bash or anything else into that file system, mount it, copy it back to the cluster, and I have this new this image again with the SBIT in it. And then, because I can also write into it, I just do this, and then I have put into the device a file system which with the same content, but also containing this SBIT binary. Of course, you now have the file system cache from the kernel. So that means you will not immediately see that SBIT binary. So you have to somehow get rid of the file system cache, which you usually are not allowed to do as user. But if you read a real large file as user, then the kernel will drop out the rest of the cache when the memory is filling up. And then suddenly somewhen this file will appear. You just sneaked into this device. Yeah, and then you can again start it because this local file system will not be mounted with no SOID, and you're root. So that's why you should always mount every global file system with no SOID and no def. So next thing is about the boot process. When you boot your own notebook, I mean, it will read the master boot record if you boot classic with classic boot mechanism. So it will read everything from the disk. Usually, when you have a large cluster, you want to do PXE boot, which means that the BIOS or the network card will on its own do a DHCP request. Then the DHCP server will answer with IP address, netmask, gateway, name server, and so on, and also where the location of the kernel and init RD is located. And then usually with TFTP, or nowadays you can also give a location with HTTP or HTTPS, where it will then download the kernel and initRD and boot that. This is usually not securable. So the kernel and initRD is downloadable also for the users who will log in after the booting is finished to a login server, for example. So you cannot secure this kernel and initRD. So there should be no secrets in it. Every user can download this location. Yeah. What the cluster managers usually do is they will then, after the kernel and initRD is downloaded and started, they will have some kind of credential exchange in the booting up of the initRD. So, for example, they set up the network and mount a NFS share, and there is a secret, or there is a root file system. This is then secure when you export this NFS share from the server side as secure. That means the client who mounts this share has to connect from a TCP port lower than 1024, which can only be opened by root. So this is the mechanism. A user later cannot do the same and cannot access this share. That would be secure. If you have a web server and say, okay, on this web server on port 80 or port 443 for SSL, there is the slash file system located, and you should download that slash file system then and extract it to a local block device or to a RAM file system and use that. This is also not secure. So everything which is in that downloadable location, a user can download too when the system is booted up. So if you have a web server where the slash file system is distributed from when you boot up, you have the problem that a user can do the same. And then you have secrets like the munch key for Slurm, or like the SSH host keys, or maybe the LDAP password or whatever is usually not readable for users in an installed node. Yeah. What you could do with a web server when you do not only just download, you could, for example, with IP tables, prevent a source port higher than 1024, and then use curl to download that in the initRD. And with curl, you can say this, which source port range or which source port curl should use. So then you could say you could use that as a security measurement. But this is some kind of not standard. The standard would be to exchange the credentials with an NFS share, which is exported secure. And I mean, don't be, if you export something insecure, don't rely on, for example, that you set up the SSH daemon, that it is not allowed to tunnel TCP ports through that SSH daemon. The user can always start his own software on the login node or on the compute node, where this own software is tunneling the ports. So that is not secure when you change the SSHD configuration that a TCP port cannot be tunneled. So if you set a NFS share to insecure, the user can tunnel always to his own laptop the NFS share, mount it on its own laptop at home and through the tunnel, and then be every user you want. And even if, and there's another possibility, there are user space software for NFS protocol. So you could, as a user, just use this software, not to mount the share, but to browse the share and copy files from that, or copy in files in that. So export, NFS export insecure is always insecure. Never do that. So next topic I want to mention here. How many networks do you need? Or how many VLANs do you need? And I would say at least 2. I mean, you could have more, of course, because we will see later this how we set up the networks in HLRN and these layers we created. But for the minimum, I would say you need 2 VLANs. One VLAN where the users are in, the systems are in, so where the PXE boot is done, where the user log in, yeah, so the access of the machines, the network where the machines are in and have full access to. This is the user network, I would say. And then you have at least another one for the BMC, for the IPMI interfaces of the machines. Nowadays, every machine has IPMI interfaces, and they are very convenient. You can shut off and and power on machines there, and you can redirect KVM, so keyboard, video, mouse, through that interface. And since we know that embedded systems are not updated very often, this should not be part of the network where the users are in. So it should be separated. I mean, you would probably also, that's why I also call that network embedded. You would also put in embedded systems there, like, I don't know, PDUs usually nowadays also have network access or network network stack where you can, for example, get the current amount of power consumption or something. Then you may have a UPS system for a certain amount of nodes, for example, for the login nodes, and you can ask, and this UPS can maybe trigger a shutdown of the nodes because the power gets empty there when you have a power problem. This should also be always protected from the user's network, because these embedded systems are very seldomly updated, and you never know if these embedded systems have some security flaws which are not yet found, which you don't know about. So all these backend services where the user usually don't have any kind of interaction with is not needed to be in the user's part of the network. And why is it not a good idea to have everything on the same Ethernet cable? I mean, nowadays, most of the mainboards offer the possibility that you share the same Ethernet cable with the system itself. So you have the system, the untagged VLAN for the system, that the PXE boot mechanism is working, and so on. And you have a tagged VLAN on top of that, on the same cable, on the same network port, on the same switch port. And you configure the IPMI interface to share the same cable and use this tagged VLAN. Yeah? Sounds like a good idea. So you have only one cable to the node, to every node. So you save one cable per node and one network port per node. Sounds like a good idea. But what happens if a node is hacked? I mean, you can always interact with IPMI without knowing the password when you are root on the system through the device file, def IPMI 0. You can use IPMI tool and configure everything without knowing any password, because the password is only for the network access of IPMI. The direct interface through the device file is always without password. So a hacker got root at the system can reconfigure the IPMI interface. And what can he do? He just unconfigures the network interface. So then it will not pick up the tagged VLAN packets anymore from that interface. And you can reconfigure the system itself, the kernel, to create another device, a network device, with this tag VLAN, and so the hacker on the system can access the embedded network. And that's why, from the security point of view, it's not a good idea to share the network interface and the BMC interface with the same cable. If possible, try always to get an HPC system where you have 2 cables per node, one for the system and one for the BMC. So defaults in distros and cluster managers. I've seen that few cluster managers, for the convenience of the administrator, I guess, trust every node from itself. So if you install a login node, if you install a compute node, if you don't watch out, you might have a root SSH key, and I mean a private key, in the root home directory, which is then allowed to log into other nodes. Yeah. So, for example, if you have login nodes, you have compute nodes, and you have file system servers, and they are all managed by the cluster manager. And if now you have a private key on every node which can log into every other node, then you would, if you don't watch out, also let a login node log in as root to the file system server. And this is a backend service which I would consider as one layer behind or one layer up. That means it is not in the user's area where the users can log in. So the most insecure servers are always the ones where the user can log in, because then every local root exploit can be used, and the hacker is already root. For a network service like a file system service, you need to have a flaw in the service itself to gain shell access to that server, and this is not so easy. If you not let the root, if you not let root logging in directly because you left the SSH keys there. No? So that's why you should watch out all the SSH keys in root home directories, especially when you have cluster managers and they may set up everything automatically for you. They might also have automatically set up a SSH key there where you can log into any other node. Then next point, the way the admin logs in should not be the way the user logs in. So the admin should never log into a login server and then from there log into a backend service. This should be prevented in 2 ways. It should be prevented by a configuration and because the secrets are not there. So the admin way to log in and the user way of login should be a complete different way. So when the user logs into the login servers and there have access to the Slurm, to the batch system and to compute nodes, and the admin should have a complete different way and also log in only from there to the user's systems, so to the login services, to the compute nodes. You should never cross log in. So if you are on a login node, you should never log in from there to another node. You always go from your backend admin node one-to-one to each system. Never log into a compute node and from there to another compute node or to a login node or to backend node back. That would be bad. Prevent that by not having the keys there and by configuration of the SSHD. We come to that later. Also, the exports. If you have own file system servers and you, for example, do NFS export and mount them via NFS, watch out that you export everything root squash. That is not a real security thing, but it makes the hacker, the life of the hacker more or less easy, because you cannot browse through every home directory directly. So you have to SU to every single user and check the home directory then. So that is, and such SU commands are usually locked and such things. So it's better, if possible, at least for the systems where the users can log in, that the file system exports are there squashed for root. So that means that the root user ID is then squashed to, for example, nobody, and cannot directly access every home directory, which is not world readable. And of course, as I said already, no SOID, no def is a mandatory mount option on all the nodes where the users can log in. And another default for the distro is that you usually have a lot of SBIT binaries. Typical example is PassWD. PassWD, nobody needs on the HPC cluster. Usually you have a portal for web browser where the user can log in and change his password. I'm not aware of any HPC system where you really set a password on the LDAP system from the login node. So this is usually a complete different way to manage the password. So you don't need any SBIT on the binary PassWD. Don't need it, but it's a default for any distro installation, of course, because on my notebook, when I call PassWD, I want to be able to change my password, of course. Yeah? But in the HPC system, you don't need it. And there's a lot of other stuff with SBITs. And I mean, I don't say that PassWD has a security hole, yeah, but you don't know. Maybe next year, a big security hole is in that binary found, and then everybody cries and say, "Oh, a whole internet is burning because everybody with shell access can get root." But it's not possible on our systems because we removed the SBIT for that binary and for other binaries from the distro too. Only needed binaries. I mean, if you use sudo, for example, you can keep it. But think about who is using sudo. Maybe only one user for, I don't know, Nagios user is using sudo. Then you can maybe change sudo to be only executable by a group where Nagios user is in, yeah? So that not everybody can call the binary. Yeah? Or SU, you can remove the SBIT for SU. You should, if you log in as root from the backend service where the administrator comes from, then you don't need SU. And you should always use sudo anyway. So that's all the possibility, all these examples just came in my mind, but there are a few other binaries. Just use a find with -perm/6000, and then you find all the SBIT and group GRD and SUID binaries, and think about if you really need them. I mean, I don't say that you should remove the binary, just remove the SBIT. Yeah, now we come to the security concept. I mean, this security concept is based generally on all these thoughts I just mentioned. So we check for every SBIT in the system on all global file systems, but the global file system should be mounted no SUID anyway. So there should be no SUID bit binary anyway. And all the installation, what do you really need? And remove everything which is not needed. Then check for services. At least if you have classes like login class, compute class, and you have the same image, then just check one booted up login node, one booted up compute node. What service? netstart -ANP, SS -ANP. Check what service is listening on what port, and do I need that service? If you don't need the service, disable it. If you need the service, do you really need that service everywhere? Or is it just for one special node which has to communicate on that service, and maybe not on all the compute nodes and login nodes? One example would be the MySQL daemon. Yeah? The MySQL daemon and Slurm means the Slurm DBD, and the Slurm DBD is not running. It's not the daemon which runs on every node. That's the Slurm D. The Slurm DBD is just running on the Slurm master node. And usually that's the same node where the MySQL daemon runs. if not, okay, then you can secure it with IP tables that only this one node where the Slurm DBD is running on can access that Slurm D through the network, and all others are disabled via IP tables. And if you have it on the same node, yeah, just let Slurm D, let MySQL D listen on the on localhost, and let the Slurm DBD communicate via localhost to the MySQL daemon. That's just one example. I mean, if you have other services which needs to run on or which needs to be available from every node, yeah, then you cannot do anything about it. But you can think about if you really need that service running as root, for example. Maybe it can run as a user. Then you should think about changing that daemon to be started as user. We come to that to one example later. Then, as I already said, root squash is a good idea when you export a file system. Root squash can also be used, can also be set, for example, with Lustre. I'm not sure if every, or I'm pretty sure that not every global file system is able to squash root to a user, but as an example, NFS can do that, and Lustre can do that too. I think BSJFS cannot do that. So, but if you use NFS Ganesha server as an example, check the documentation. The default of Ganesha NFSD is to export NFS insecure, not set in etc exports, where you can set it the options and say insecure for one share. It's default for everything if you don't say anything. So check your NFS. I mean, if you use kernel NFSD, then the default is secure. But if you have NFS Ganesha running, check if you export everything insecure. And if you export something insecure, it's really insecure. Every user can say I'm root and read that file, which is only readable for root, because every user can start their own libnfs and without mounting, just communicating with the NFS daemon, and also tunnel the NFS ports, as I said, with SSHD or with own software to their home. Yeah, and already also mentioned no SOID, no def is mandatory for all global file systems. Yeah, and as I said, SSHD, think about from where should root be able to log in? Is it really necessary? Is it also possible to log in as user? From where as user? So even when I set up a backend service where the admin logs in, the admin login server, it should not be possible for the hacker, even if he got the root private SSH key, which is allowed to log in as root to that service. It should not be possible because he comes not from the right IP address. So the admin comes from some kind of staff network to log in directly to that node, but the hacker will come from one of the login nodes or from one of the compute nodes. And the SSHD should be configured as such that it not allows to log in from there. It should only be allowed to log in from the staff network. And also maybe not as root directly, maybe as user, and then sudo to root. So that should be the default way the administrative work is done. And we come to that later, to these classes or layers in the next slide. So all SSHD configs should allow only from login from a higher layer. We come to that later. But this involves exactly what I said, that we log in only from the staff network, which is trusted. Yeah? And you can do a further step. You can, in addition to the SSHD configuration, set up IP tables so that you not even can reach the SSHD port from login servers and compute nodes from this server, because you don't need any SSH communication from that network. So you can just disable the port in addition. So if the SSHD has a flaw and somehow you can gain user access or even root access through the network somewhere, it's not even then possible that the hacker can log into a backend service, because the SSHD port is not reachable via IP tables configuration. And what we did in the HLRN, because we are here in the HLRN requirements for the vendor, is that we said, okay, we have a jump host where every admin has to jump over, and the main administrative node let the users only log in from this jump host, not even from the staff network. So we have to go through the jump host to the administrative node and be there a user. So I log in over this jump host where I don't have shell access. I only have the possibility to use this host as a jump host. I use this as a SSH jump host to go to the administrative main server. This server lets me only in if I come from the jump host. Everything else is blocked, and only as a user. And then I say sudo and have to give the root path, not the root password, the user's password as a second token to become root. So I know that's not really two-factor, because it's both things you have to know. So SSH private key and the password of the account I log in. Two things the hacker has to know, and also has to come from the right IP address, of course, to be allowed to go through the jump host. But it's at least two things he has to know. So it's more than having to know only one thing and being directly root. And we also involve sudo in that sense, that we can log who did when a sudo call. Come to that later too. Yeah, and as I said, a service which is reachable from the login nodes, from the compute nodes, you can think about if that is really needed as root. I mean, most services from centers from the distro did already think about that. For example, I don't know, the postfix service is running already as user postfix and not as root. But if you set up your own stuff, like IPMI exporter is one example. Yeah, okay, IPMI exporter does not need to be used by the user, so you can prevent it to that the user can reach that port. But the default is IPMI exporter is running as root, opening a TCP socket, a TCP port, and being reachable there. So if IPMI exporter has a flaw, it's not only a flaw that you can gain this user, you would already be root. So that's why we did that. We didn't do that. We let IPMI exporter run as a user, change own the device /dev/IPMI0 to that this user, this Nagios user, can then read and write to that device. And that's everything you need. So then this service does not need to be run as root. That's one example. So the layer model in HLRN. So as I said, the admin way to log in and the user way to log in is a complete different way. So from this layer on the right side, the admin comes from the top one. So it logs, he logs in on the layer 0, Schicht 0. While the user comes from the bottom and logs into a login server or access node in the layer 3. And all the configuration of SSHDs and IP tables should be configured like that. When you are in layer 3, for example, it should not be possible to log in to a higher layer. So we have the service layers like the file system servers, then we have the admin masters, which is in this case what I already said. We have this jump host, which is the admin gateway, and then we jump to the admin master. Then we are already in Schicht 1, in layer 1, sorry. And from there, for example, we are not allowed to log into repository server because it is a layer above. So how can we get to the repository server? Using the jump host to directly log into the repository server. So the jump host lets you log into layer 0 services, while if you go through the admin master, you want to configure something in the cluster, then you will not go to the higher layers back. Now that's the main idea here. More maybe is not really needed to say. Sometimes it's also forbidden to log in the same layers. For example, admin master and image master in the same layer 1. And we forbid to log in to the image master from the admin master. Why? The image master, so the admin master is our Bright servers, and Bright is a proprietary software where we don't have sources. They listen on at least two TCP sockets for the whole cluster, and it might be a security issue there. There might be one. I don't say there is one. There might be one. So it might be the case, and this communication has to be possible for boot process and also for when the system is up for monitoring and stuff like that. So these ports have to be open. Also, you have for the whole PXE boot process, TFTP server, DHCP, and stuff like that is running on the admin master. So on the one hand, it's secure because we configured the SSHD and so on, and it's in a very high layer. But there are so many services which has to be reachable from the whole HPC system that we say, okay, the images are on another host, and these images, there is the most work done. Yeah, these are basically the slash file systems of all the classes, and we administrator these installations on a different node, and when we do changes there, we async to the admin master later. And we push from the image master to the admin master. So admin master cannot log into the image master, but the image master can log into admin master and can then push the changes with async. So that's why we separate, even if it's written here on the same layer. Image master is more secured, has no services except for SSHD. The SSHD is only configured to be able to log in from the gateways. So only admin can log in from the admin gateway. And if we have a security problem on Bright and a hacker really got access to the admin master, we have still the images which he cannot tamper. Okay, then we come to DFN-CERT recommendations. As I said, we asked the DFN-CERT to review our system, and we allowed them to log in as administrator in the same way as we log in. Opened one IP address from DFN-CERT to be able to log in and gave them access. And then they had a look on our systems, and we found a few problems we didn't think about, and that's why I want to mention them here. First thing is, we didn't think about IPv6. That's usually not a problem because you just make the systems reachable via a different IP address. But if you don't configure any IP tables, so any firewall on the systems, then the default is, of course, to allow everything, to accept everything. Input, output, forward rule is accept. default policy. And that means if you, for example, have this IPMI exporter, what I talked about as an example, we said, okay, IPMI exporter has to run on every local node, on every compute node. It's on a specific port, but we block this port from localhost and also from all other IP addresses, except for the one where the Nagios server is running on. So then the Nagios can reach that port, but the user can never, because he is so it's blocked from localhost and also from other to any other IP address. But this is set with IP tables, and if you don't set IP6 tables, the default is to accept everything there. So it was still reachable via IPv6. Yeah. So you should somehow disable IPv6. I mean, you can do it with a boot command line parameter to disable IPv6 in the kernel, but there are problems. There's certain software which has to be specially configured when you don't have IPv6 stack in the kernel running, and that's why we didn't want to do that. You can disable IPv6 on network interface level, but then you have to think about every name of any possible interface, and that's why we just chose the easiest way to just say we drop everything. I mean, the stack is there, interfaces have local, so this local config IP addresses with the MAC address inside, but we just say default policy except forward output, no, not except, input forward output to drop. So then you cannot communicate with IPv6. Yeah, and then there is this audit daemon, which logs certain amount of calls which you can configure. Default is that it does not log anything, and probably also that it by default does not start. But this is something you should really think about, and I have a few slides with configuration on it, and these slides are just for you later, that you, when you have the slides, that you can maybe copy paste stuff you find necessary or important, copy paste that from the slides. We won't go through every slide there, but when you boot up and before the audit daemon is running, nothing is logged usually. And you might have flaws already on the boot process. I mean, it's not very likely, but it is possible. And the other thing is, the hacker could kill the audit daemon, of course. Then after the kill of the audit daemon, nothing is logged anymore. That's why the kernel should, if he cannot load off to the audit daemon, because it's not yet running or not running anymore, it should log in a kernel buffer. And this is done with the kernel command line parameter audit equals 1. And the default is that it logs 64 lines of entries, which is not much. And that's why the second recommendation is to set the limit to 8,192, sorry, which then logs 8,192 log entries until it discards the first ones. Yeah, and check etc passwd if you have some accounts from system daemons which have shells. We had that. I mean, I think they came all from Bright, but I'm not sure. Maybe CentOS or Red Hat has also some services where the bin bash is in the file for that user. Check if you need it. If you need a shell for that user, mostly if it's just a daemon, it's just a system account, you probably don't need a shell for that. So you can put it to bin false. SBIN no login is the same, yeah. So bin false or SBIN no login, it's the same. It's just that you don't have a valid shell there. Then SSH deconfiguration. The defaults, especially for these old enterprise installations, is mostly not optimal. So there are encryption algorithms and hashing algorithms accepted, which are known to be broken already. The last one, which is also not very secure anymore, but is needed for older libSSH implementations, is HMAC SHA2 512, which is the highest number, 512, which you can allow. We allowed this for older libSSH configurations from clients. You would think, I mean, libSSH is not the same like SSH client. So, for example, my OpenSUSE installation here, I tested after we disabled all these older algorithms. I tested if I can still log in, and we tested older installations, and it was possible. I don't know, for installations 8 years old, but the libSSH implementation is still needed on my current version of OpenSUSE. Still needed this old algorithm. So we had to allow that. But on these links, you can read a bit more about what algorithms to disable and what algorithms not to disable. Okay. Yeah, and also if you have SSL TLS systems, so I don't know, web servers or something, just check if you allow vulnerable cipher suites for HTTPS, like RC4, low, so small key lengths, RSA 1024-bit and stuff like that. Also, if you have signatures, so certificates, which are used, for example, for the boot up process or something, MD2, MD4, MD5, SH81, they are weak. I mean, they are weak. I mean, they are not broken, but they are weak. So also SSL version 2, SSL version 3 with HTTPS, disable it if you have a web server, and check if your services are still running. It's a good idea to disable these old implementations or this old stuff. Yeah, then we come to sudo. The first point here is this use PTY thing. I've seen in the newer versions of sudo, this is default, so you don't have to set it anymore. Probably with RHEL 8, Rocky 8, or whatever you will use for the version 8 of RHEL. It's probably already set via default. Even if it is not in the config, it is still the default. But for example, for CentOS 7, it's not the default. That means if you do a sudo call, then you will not get a new TTY within that sudo. And especially if you don't do sudo to root, but to another user ID, this user will not have an own TTY. Somehow this is also security related. I didn't understand actually why, but it is also some kind of use case related, because if you use something like pass with uses GPG, then the password is read from the TTY, and if you don't have read and write permission to your own TTY because you got via sudo this user, then it will fail. So yeah, DFNCert recommended to set defaults use PTY. Then you will get your own TTY every time sudo is called. And this somehow has also something to do with security, but also you might have problems if you don't set it. So that's what I want to to say here. The second thing is sudo by default does not lock anything. So if you are already setting defaults, just set also lock output, and then you can use sudo replay, which is quite nice. Sudo replay -L just lists you the last command, or all the commands which are issued with sudo. This is quite nice for, I mean, if you say sudo -E or sudo bin bash, then only this is locked, of course. And the rest which you do inside of the bash is then not locked anymore. But if you can somehow agree to all your admins that you only issue sudo commands which do a real command and not spawning a shell, then you would have with sudo replay and these defaults lock output a complete history of what who issued. This is quite nice. Yeah, now we come to the already mentioned audit deconfiguration. I don't want to go into all the details here. This is what the DFNZ was recommending us. So this thing is about date and time modification. So if the hacker got root and tries to modify the system time, then this would be locked. That's why UID not equals 4 to 1 is I included here. That is exactly the user ID our NTP stuff is running. So to not lock have a lot amount of time change locks, I just excluded the NTP user from being to lock. And of course, if the file etc local time is changed, this should also be locked. And then here a lot of more files, when they are modified, this should be locked. Then you have here, if the host name is set, this should be locked. If some of these files are changed, should be locked. This, I mean, we don't have SE Linux running. You probably also don't have it running. I mean, Bright is not supporting SE Linux, and I'm not sure how many power impact you have when you use SE Linux on top of the system. We don't have it running. Would be a good security gain if you could set it running, but you have a lot of hassles, I guess, with a lot of software if you want to configure that in the right way. It's not like Android system, which is some kind of compact and from one vendor, and Google can set the SE Linux right for everything. The HPC system is more complex in that way, that SE Linux is pain in the ass in the end. But if you manage to get it running, yeah, then it would be good if somebody could get around the SE Linux and still got root. That when he changes these configuration files, that it is locked. Also fail lock, last lock, and for special PAM modules, if that is changed, should also be locked. Then, of course, if you log in, I mean, if you log in, it is changed, of course, should be locked. If a hacker is manually changing it, timestamp should be locked for these files. Then if you change own or change mod something or set extended attributes to a file, should be locked. What we did not lock is removing or creating files, because that would create a lot of lock entries, I guess. So that's something we do not lock. Here, trying to read or write a file which you have no access to should be locked. Could create a lot of entries, maybe not. We just set it now. After this recommendation, we will see how many lock entries that will create. And also something I find quite good, because it does not create much locks, but maybe it's a good thing you later want to know if something was mounted somewhere. So every mount should be locked. Also, if somebody tampers is with etc sudoers or etc sudoers.d, should be locked. Also, of course, the sudo log files itself should be locked. And also very important, if you load a module, or remove a module. So if you change one of these binaries, but also if you load a module, it should be locked. And for me, the most important thing, because I think most hackers will do exactly that, something we just talked about at the beginning, is the SUID or sgroup ID calls. So if a hacker got root, probably this root exploit was some kind of a hassle and took some time and maybe some, I don't know, some CPU usage and stuff like that. And when he finally got root, he usually wants to have an easier way to get root again. So he will somewhere store a S-bit binary to call it as a user later and get root directly. And he will try out if that works. So if somebody calls a S-bit binary on our systems, it will be locked. So a S-bit binary which has a SUID root or sgroup ID root ownership, yeah? And will then run as root group or root owner. This is locked without a daemon, and we have on the syslog server a nightly script which checks which calls were on the last day, summarizes that, which calls there are, and sends a mail. And I go every day to that mail and check if there's a binary which we don't know of, which was called. And also very important in the end, the audit daemon can be or the configuration of the audit daemon can be set immutable. So it cannot be changed afterwards in the running kernel. So if you set this, the hacker cannot disable these locks because he cannot change the configuration afterwards. Okay, and then last thing, we have 4 minutes left. I try to speed up. Yeah, do you allow mails to be sent from the cluster? If yes, you probably have one central mailer which accepts mails from all the compute nodes and all the login nodes. I mean, Slurm is sending the mails from the Slurm host. You could probably, if you only want to allow Slurm to mail, you can probably only allow this host to mail, and this is a host where users cannot log in. But if you have cron jobs on the login nodes, compute nodes running, which should send emails when there's a failure, I don't know, smart, for example, smart daemon, if the SSD is failing, should send a mail. Yeah, you want to have mail possible and mail in place. But there are, in the end, 3 possibilities the user can send mails. So one is to use the mail pipe post drop on the system itself. One is to connect to localhost on the same system where a postfix is listening, and usually in a default configuration from localhost it will accept mails. And of course the central mailer also has is accepting mails from all the login and compute nodes, so the user could connect directly to that port. So what you should do is have this set up that it does some kind of authentication. So that is a shared secret which you can store on all the compute nodes and login nodes, which is not readable by the user, only by root. Of course, if a hacker already got root somewhere, this secret is also gone. But for not, so this is meant here not for the attack of a user gaining root access, but the user want to spam out and using your mailer to spam the world. Yeah? So if you got not root, but just want to spam the mail, there's when you set up shared secret here that these postfixes, so these nodes are only allowed to send mails here with authentication. The user cannot directly connect here. And you can set the postfix to not accept mails from port 25, only from post drop from the internal mechanism. Then you are safe on these 2 things. And then you want probably a from restriction that he cannot spam through the mail binary, for example, through the post drop mechanism. This is possible. next slide. No, not on this slide. Let me see. This is possible with postfix since 3.6. When you look in the postfix version, you have in CentOS 7, it is 2 dot something. So it's not, so this will not work. But you can just compile the current version and just exchange the binary post drop. This is enough. Then this configuration is also working in the older postfix versions because post drop is reading that. And then you can restrict here that the user can only mail from user ID at HLRN.de, for example, from the email address, which is user ID at a domain. Yeah, and so if he tries to spam, he will always spam at the user ID, and this will hopefully then quickly seen. And you know which user, and you can, and this user ID can be just dropped out because it's only act. So then you have a bit more security on the mail side. And here's also for your later copy paste if you want how to set up the central mailer with other configuration, other authentication, the client. No, this is a client, this is a server, and my networks equals empty string means that the postfix nodes here will not allow any unauthenticated mail on port 25 anymore, even from localhost. And this is to prevent or to force the user to a special from address. Yeah, and that's it. Do you have any questions?
I have one.
Yeah.
I'm pretty sure that when you do an update with the package manager, that some packages set the ownership. Do you have a mechanism for checking the SUID bit if you do an update? Or
yeah, I mean, I do a find before I do updates, and then a find after. So find minus perm /6000 before and after the updates, and then I just there's no automatic mechanism, but then I find the differences and set it again.
Okay, thanks.
And you should so you do a find with perm /6000 to get group GUID and SID binaries, and then you should pipe it with xargs in ls-la or L because then you see the real ownerships and what exactly is set. Because it's not enough just to find the files. You will later want to know which was how configured. But yeah, I do it manually.